Okay, so this is the code explanation behind my IoT data trading user study platform, going into details about the implementation and about the different technologies used. So first of all, I thought it would be relevant to discuss how to get the project up and running in case any future people want to do so. So we're going to be going through installing the requirements, setting up the correct environment variables and the database, and then eventually running the project. Okay, so once you're in the folder where you have downloaded the code, we want to take one step back, and now we're going to be installing a Python virtual environment. So this command will create the virtual environment called env. And once that's created, we can go ahead and activate it using this command. So once it's active, we're going to use the package manager brew, which is, I'm using Mac, so I'm using brew as a package manager for things outside of Python. And that will depend on what system you're running on, which package manager you decide to use. So we're going to be installing this package called WK HTML to PDF, which is used in the project. So once that is installed, we can now go ahead and go back to that folder we were in earlier, and we can install the Python packages for the project, which are stored within this requirements.txt file. So we do pip install. And this will install all of these packages found in this file here. Once all the Python packages have been installed, we can go ahead and set a few environment variables which are relevant to the development environment for the project. So Flask app points towards the entry point for the application, kind of where the application is instantiated, which is within this file here. And then we're setting the environment variable for the development configuration. So once you've set those environment variables, there are a few others that you'll need to set to set up and be able to run the project. They're all found in here, so you can either use the export and then the environment variable name to set up these environment variables, or the way I like to do it is modify your bash profile, which means you don't have to use this export command to set the environment variable every time you open the terminal again. Folder for the schema migrations for the production database, and we want to keep the development and production migrations separate. So do not interfere with any of the production data or the schema that's running on the production side. So to do that, we're going to need to initialize a new directory to store the migrations in for the development database. Once that's been created, we can then migrate the changes from the schema found in this models file here to the so once we've created the migrations dev folder, we're going to need to migrate the schema found in this file here to some commands which can then go and update the development database that we have. So we're going to use this migrate command to do that. So what that's done is basically created this file here, which converts all the code found in the models file we were looking at earlier into commands which are used to create the schema in the database that we're using. And at the same time, it's also created this app.db file here, which is a SQLite file, which is what we are using in this project for the development database. So once we've migrated those, the schema to these commands here, we can then go and run the upgrade command, which will apply the schema to the development database. So once that's run, the database now has the schema. So we can then go and run the actual project now. And as you can see, it says running on and the location here. If you visit this in your web browser, you should be able to see the project running. So earlier we set the Flask app variable, which points to this userstudy.py file here. And what the important thing that this file does is it basically creates an instance of our application. So when we're importing anything from this app folder, what Python does is it runs this init file here. So first of all, we're importing all the Flask integrated packages that we're using and creating an instance of them. And then we're using this create app method from the init file, which effectively creates an instance of a Flask app. We're setting up our environment variables and our configs here, depending on what Flask env environment variable we set earlier. In this case, it's the development config. All of these can be seen in this config.py file. So we have the default config and the production, development, and test. We're then adding the application to all of these different packages these Flask packages we've installed earlier. This sets up a Flask AP scheduler, which is something we'll be discussing later. And down here, we are adding the blueprints from the different folders found in here to the actual application. Now, what a blueprint does is it encapsulates functionality. So each folder is a blueprint, and you're effectively registering all the endpoints in your application to the actual application. And this is kind of done through a hierarchical order. First, each endpoint is added to the blueprint for that specific module, and then subsequently the blueprint is then added to the application. This kind of separates your code and means you don't have a mess of adding lots of different endpoints to a single application. Going further down, I decided to add this logging functionality, which basically is mainly used for production and sends me emails for errors that have happened within the application, or for less important things, it logs it to a file. Yeah. It's also important to note that each module contains this routes.py file, which registers a route to the blueprint, and using this decorator here, this app bp.route. So basically, say you visit /login, it will run this this code found in here, and commonly what you'll see is these kind of return these redirects, which basically redirect the client to whatever's the parameters passed in. Or often you'll see this render template, which will render the this HTML with the given parameters as well. This models.py file earlier, and I'm using Flask SQL Alchemy, which is a wrapper for SQL Alchemy, which is a object relational mapper. So here you can see multiple classes, and each class represents a different table in the database. So here we have the user table, and each attribute within the class is a column in the database. So ID, username, password hash are all different columns, and you can also create these kind of helpful methods for the class as well to kind of stop you from reproducing code everywhere and making it simpler to interact with an object. So also you can define relationships between different tables using Flask SQL Alchemy. This kind of points to this user group table, creates a relationship with the admin table. So you can also create relationships between two different tables. So here we have a relationship between the study table and the response table, which is found lower down. And so it's saying that a study can have multiple responses. And you can also specify this backref parameter, which basically creates a similar kind of column when the tuple is converted from into an object within the code from the database. So it's kind of handy for trying to find kind of the reverse of the relationship. So now we're going to be discussing each of the implementations of the modules for the project. This will cover the forms, the endpoints, some of the JavaScript run on the client side, as well as some of the more interesting HTML elements. So stepping into the first module, the authentication module, which handles the logging in and logging out of both participants and administrators from the application. The first endpoint here, the login endpoint, checks to see if the user is already logged in, and if so, they are redirected to their landing pages after login. If they are not logged in, an instance of the login form is created, and let's take a look at that login form. The login form inherits from FlastForm, which is the form package that I'm using for the basic forms throughout the application. The login form possesses attributes which are each an instance of another class and represent different types of field, such as string field or password field. When you instantiate some of these fields, you can pass validators for the field to the validators parameter. Here, the data required signals that the field must be filled out by the user. The data required validator is one which is already implemented by Flask Forms and not by me. If the client is performing a GET request rather than posting the forms, we render the HTML for the login page and return it to the client. By passing the form instance to the render template function along with the HTML file, we can use the attributes from the form instance within the login HTML file. Using the Jinja 2 templating engine baked into Flask, this syntax allows for dynamic content within the HTML file. You can see the syntax here, adding the label for the field, rendering the field itself, and displaying any errors upon validation based upon the objects passed into the render template function. If the form is posted to the endpoint along with the user's username and password, the form.validate on submit method allows for automatic validation of all the form fields against their validators. If the form is invalid, the relevant errors would be added to the form and the form would be subsequently re-rendered along with those errors. If the form is valid, first the user is retrieved from the database, if it can be. Their password is then sent. The password that they've sent in the form is then hashed and compared with the one that is stored in the database as well. If it's not valid, then they're not logged in. By passing all of these requirements, the user is if the form is valid and the user can be retrieved from the database and their password is valid, the login user method is called, which is implemented by the third-party Flask login package. This method stores the user information in the session so they can access protected endpoints. The logout endpoint uses the logout user method, also implemented by Flask login. It removes the user's information from the session so they can't access protected endpoints and redirects them back to the login page. The next module we'll be discussing is the participation module. This module handles all of the participation within the study, both submitting information about themselves and actually responding to the study. You can see plenty of decorators within the routes file besides the bp.root decorators seen earlier. These wrap the endpoint function and are run before the code inside the function is run. The login required decorator implementation is supplied by the Flask login package mentioned earlier and prevents any unauthorized user from accessing the endpoint. The other decorators shown are implemented by me. So let's take a look at some of the decorator implementations. Here we can see the decorators for the module, each performing different functionality to protect the endpoint. The valid participant required decorator is used to decorate the study endpoint. It validates that the participant attempting to access the study is one which they are actually participating in. The check complete study decorator checks if the study has been completed, preventing them from accessing the endpoint if they have already completed the study. The check not complete study decorator prevents access to the endpoint if they have not yet completed the study. The participant required decorator validates that the logged in user attempting to access the endpoint is of the type participant and not an administrator. The completed info form required decorator validates that the participant information form has been filled out, preventing them from bypassing it and accessing other endpoints. So the index endpoint renders the HTML which contains details about the study, such as its description and start and end date before the participant selects to begin the study. This index HTML can be seen here, displaying the study description, start, the end date, and so on. This HTML also contains a modal which displays an embedded video to show the participants how to respond to the study. The modal here, along with much of the other CSS, is using the Bootstrap toolkit. So going down to the user info endpoint, this endpoint first instantiates a user info form, which will show within this forms.py file in the module. Now, what this form consists of select box fields with choices generated from JSON files, which we can see one of here. The JSON files contain key value pairs. The key is the one sent back to the server. This is the key here, sent back to the server if it is selected, and the value is the one which is displayed to the user on the interface. So going back to the endpoint, if the form is valid, using this validate on submit, which checks all the fields are valid based upon their validators for that field, then each field is stored in the corresponding attribute for the participant who submitted the form. The study route up here is the most interesting, and relies on a few components. You can see the request.getJSON method getting the JSON data from the client posting something to the endpoint. This JSON data is scraped from the web page using some JavaScript and is sent back to the server, which I'll show now. So once the participant clicks the submit button, the functions here basically get each card and its position on the axes, as well as the values entered by the participant in the grid, and the positions along with the values. The positions and the values are then stored in an object further down here, and then this object is sent back to the server using the Ajax. Within this function as well, there's some validation upon some in the form, checking that they've filled out the correct values and they've placed all the cards upon the grid. And if not, there is an error shown and the data is not submitted back to the server. At the top of the file, you can also see another function which adds the jQuery sortable functionality to the cards, allowing the user to drag and drop them onto the axes within the study. Once that JavaScript object is retrieved by the server, it is serialized using the convert response function. So this function creates tuples in the database for each card in its position here. Similarly, each numeric value and its column and row position is also stored in the database. So that sums up the main implementation for the participation module of the project. So the next module we'll be discussing is the administration module. It is one of the largest out of all of the module, and handles the creation and modification of user groups, card sets, and studies. So let's take a look at the endpoints implemented in this module. So first off, the index endpoint uses this admin required decorator and all the endpoints within this module will use this admin required decorator. And what this admin required decorator is doing is checking if the current user who is logged in is of type admin, so only the administrators are allowed to access any endpoint within this module, kind of to prevent any other people from modifying or viewing any data relating to the study's user groups or card sets. So this endpoint, first of all, grabs all of the objects for the administrator that's logged in, which they've created, and provides it to the index template, and which renders all of these studies, card sets, and user groups in a nice way to kind of see an overview of what the administrator has created. Next, the study endpoint uses another decorator, the valid admin required decorator. This takes a parameter called model, and in this case it's a study. The parameter is set as a study because the endpoint we're accessing is related to a study. And now what this decorator does is, based upon the model parameter, so in this case the study, it checks whether the study ID that they're attempting to access via the URL, this ID here, is one which they've actually created themselves. So we're querying first for the study based upon the ID that they've entered in the URL, and we're checking whether the study creator is of the current user. And this prevents any other administrator from accessing other administrators' resources in the application. And this kind of same method is used for the user group and card set endpoints as well. So first of all, in the study endpoint, the study form is instantiated, and let's take a look at this form. So the form contains a few notable fields. The query select fields provides the choices based upon a database query rather than a static set of choices. The file field here allows the uploading of a file given its extension provided in the file allowed validator. The custom validator lower down in this validate function validates specific constraints of the form, such as the start date not being after the end date. So looking back at the study endpoint, here are the actual queries for those query select fields, and if the client is posting the form, again we use this validate on submit to check if the form submitted is valid based upon the custom validator method and the validator parameter for each field. So the study, and if the form is valid, the study attributes are set to the corresponding field data as entered by the user. And also, interestingly, here you can see the form image data. So the image actually uploaded by the administrator is the file is created within the file structure here, so it can be retrieved later on. Once all these attributes have been set, you can then see this db.session.commit, which commits all these the changes to the database, commits all the changes to the database throughout all the endpoints which modify data in the database. You'll see this db.session.commit to commit all those changes back. Otherwise, there'll be no kind of reflection of any changes in the database. If the client is performing a GET request at this endpoint, each form field is populated with any corresponding existing data from the database. And yeah, so say if they've already entered information previously, they've already filled out the form and they want to modify it later on, this will basically provide the information in the form field which they've already entered previously, so they can see what they've entered before and potentially modify it. Okay, so moving on to the next set of endpoints, the card set endpoint, which handles the modification of a card set, and lower down the user group endpoint, which handles the modification of a user group and lets the administrator fill out the form for adding new cards or adding users' email addresses in the user group here. So both the card set and user group endpoints follow a similar kind of pattern to the study endpoint, either processing form data or populating field data, but notably different as a result of kind of using this hierarchy where cards belong in a card set. If a card set is modified, we don't, based upon the new values that are submitted back to the server, if they've modified the form, we can't really tell what's actually been updated in terms of the actual objects within the database. So we just delete all of the previous objects associated with the card set, or in this case the user group down here. See them all being deleted, and then subsequently they're then created again within this for loop here. So we're adding the image to the file system and creating the new cards based upon the form. And again, you can see the population of data if the client is performing a GET request. And this kind of structure is also replicated in this user group endpoint. One interesting thing to note is to within the actual, both the card set form and the user group forms, so the user group forms there, card set forms here, one of the attributes is actually of a type field list. So the field list allows you to add any number of subforms to a form, and each subform represents a card or or in this case a user in this field list there. And you can see those subforms up here. So they're a new, they're a different class, and they contain like a different, each having their own kind of fields. So in order to allow this kind of functionality of having any number of subforms within a form itself, within the user interface, I used a JavaScript plugin called czmore, which allows you to basically duplicate elements within the DOM. So in this case, I used czmore to duplicate the subform elements of both the the card form and the user form. So any number of users could be added, or any number of cards could be added to a user group or card form, card set, respectively. So also as a kind of a nice to have feature here, there's also another JavaScript file which allowed you to upload a CSV file, and for each email in a CSV file would use the CZMore plugin to duplicate the subform in the user group form, and then enter the email into the value of the input field that was created. Finally, within the this administration module, to allow the administrator to create and delete studies, user groups, and card sets from within the interface, I also added all of these endpoints down here, which effectively these ones with new prepended to the function name all created their respective study, user groups, and card sets, and that will create the object in the database and then redirect them to the page where they could fill out the form to actually assign the attributes of the specific object that they wanted to create. Similarly, the delete methods within the module deleted each of the study, user group, and card set, removing them from the database entirely. So I previously mentioned this scheduler. What the scheduler does is it adds this check studies method to the job list to be run every hour at 5 minutes past every hour. And what this scheduler job does, which is specific to the administration package or module, is that so what this check studies method does is it queries the studies that have a start date of today, loops over those studies, and obtains the user group for that study. And what it does is for each user within the user group, it creates a password which is a random string and sets the password to that string. Now, I also render a HTML template with some information, including the user's username and password, and I create a message. This is a class written by this Flask Mail package which I'm using, and then I send this HTML containing the participant's username and their password to them, so they have an email with their credentials in order to be able to access the application. There's also a flag that is set for the study saying that the mail sent to the users is true, meaning that because this is queried every 5 minutes on every hour of every day, could be the case. It will be the case that say a study will be queried 24 times a day, and we don't want to be sending 24 emails with new passwords upon the day of the study, and we just want them to be sent once. So this is why we have this mail sent flag. Okay, so moving on to the responses module. This module is the most advanced in terms of the implementation of throughout all the modules. It includes the parsing the data, producing a variety of graphs, creating PDFs, things like that. the module analyzed the response data created from the convert response method shown earlier. Each endpoint in the module uses a method or methods from the parsing package here, which passes the response data for a study in a different way, creating different representations of the response data, which other methods in the parsing package may miss out. So decorators throughout this module are the same as used in the administration module, as this module is kind of used only by the administrators. So the same decorators can be used in this case as well. So the first general endpoint uses the get card X responses and the get card Y responses method from the parsing package. So let's take a look at these methods. So both methods iterate over all of the responses, counting the frequency of the position where the card was placed on the axes, here. Then using this data, I use the Python visualization library called Bokeh, which is used to plot the data gained here into a bar graph. The components method down here, provided by Bokeh, returns a script and a div string, which is then returned back to the endpoint function here. So both scripts and divs are passed into the render template function here as arguments, so the bar chart can then be rendered with the interface. The script here is JavaScript, which actually renders the bar chart, so I don't have to write any extra code to render the bar chart. It's done automatically through Bokeh. Moving on to the heat maps endpoint in the responses module. If the client is performing a GET request, initially a form is displayed to them here. You may notice that unlike the other forms seen in the previous modules, there is no form class being instantiated anywhere. Instead, the form is created purely in the HTML in here. Here's the form. And the Jinja syntax is adding the options for the form, for the select elements in the form, based upon the objects provided in the render template arguments. The administrator selects a card from each card set. So one of these options, and a type of heat map they want to add. Instead of posting this data directly back to the server, instead, upon the administrator clicking the add button here, this JavaScript function is called, which basically takes the options selected by the administrator and adds them to an object and sends that back to the server here using this Ajax method. Once that object is sent back, this as the request.method is post, this section gets run, and depending on the type of heat map selected in the form, create one heat map or create one heat map count object is instantiated. Both of these classes inherit the create heat map class, which we'll see in a minute, and the add method is called on these objects, and the arguments are the options selected by the user in the form. Now taking a look at this these classes. So once the add method is called, in turn calls the create plots method of the specific class that's been instantiated. So and each of these create plot methods set up different values to be used in the creation of the different heat maps. So create one heat map class calls the calculate price method here. So let's take a look at the calculate price method. Now what this method does is iterates through all responses, obtaining the positions of the card selected in the form here for that response. From the combination of these two positions, we can then calculate the position of the numeric value on the grid, which represents the value placed upon these two pairs of cards selected in the form. The calculate response max and calculate response min are used to normalize the participant's response to prevent differences in units of measurement affecting the values in the heat map across all responses. The values array here holds the total of the normalized values across all responses at every position on the grid. The position of the numeric value obtained earlier is used to locate the total within the array and increment it by the normalized value calculated in this loop. Each total normalized value is then averaged to get an average normalized value across all responses in this section here. It is added to a different array called data, which is formatted in such a way so that the visualization library Bokeh can derive a heat map from it easily. The create one heat map count class and its create plots method calls the calculate count method rather than the calculate price. So let's take a look at the calculate count method now. So this method iterates through each response, obtaining the positions of cards selected in the form from that response here. We can then calculate the intersection of these two positions to get the position on the grid. The values array stores the count of the intersection for these two cards across all positions in the grid. The derived intersection value from the response is used to increment the corresponding count in the values array. You see it's incremented here. So then we end up with a count of the intersection of the position of the two cards selected in the form across all responses. This array is then added to a different array called data, which is formatted in such a way, again, so that Bokeh can use it to create a heat map easily. So once the respective calculate count or calculate price methods have been run, the data obtained from these methods is passed into the create heat map method along with a few options. Now what this method does is it's basically just using the data obtained in those calculate price or calculate count methods to produce the heat map. So it's setting up all the options, plotting the data. See some of the options here and formatting it so it makes sense, and then is adding the script and the div strings to the object, to the plots up here, to the plots method, to the plots attribute, sorry. These plots are then passed back to the AJAX method in a response. So if we look at the JavaScript again, upon success, the add. So if the AJAX method receives a response, the add heat maps method is called with the response. And what this add heat maps method does is just add the script and the div string seeing. It adds the script and the div string to the DOM, so it can be rendered on the screen. So you may be wondering why the form used doesn't use the form class as used in other form examples. This is because using that method means the whole page would have to be reloaded upon adding a new heat map and would lose any previous heat maps added. AJAX asynchronous design allows us to pass data between the client and server without reloading the page, meaning that many heat maps can be added, allowing for a simpler comparison of data. So the compare responses endpoint uses a similar method to the previous create heat map endpoint, rendering a form and sending the form data back to the server using AJAX for the asynchronous functionality it brings. It displays two responses as the user entered them on the actual study interface. It does this by reusing much of the HTML components from the HTML used in the actual study. The form also has an option to display an average response. This average response is calculated using the average response method, which we will look at now. The average response method up here uses submethods to calculate the average for different parts of the study, such as the average position for the cards placed on the x-axis, the average position for the cards placed on the y-axis, and the average for the values placed put into the grid. So looking at the average values for the numbers placed in the grid, it first creates an array to hold the total value for each position in the grid over all responses and the number of responses who have given a value in that position in the grid. And then it loops through each response, adding the normalized value to the running total in the array for each position on the grid. It also increments the count in the array for that position. After all responses are looped through in such a fashion, the total is then divided by the count for each position in the grid to get the average normalized value. To get the average position for the overall responses for cards placed on the x-axis, first an array is created to hold the total of the positions of each card on the x-axis and the count of the responses who have placed the card on the x-axis. Each response is then looped through, going through all their card positions and adding the position of the card to the corresponding card position total in the array. The count is also incremented for that card in the array. After all responses are looped through, the total position for each card is divided by the count for the card and rounded to gain an average position on the x-axis. The same functionality occurs in average card positions y, but rather than going through the cards placed on the x-axis, we're going through the cards placed on the y-axis. So upon running all these methods, you gain the average position of the cards placed on the x-axis, the y-axis, and the average normalized value of all the numbers in the grid. So this average response is passed back as a response object. Depending on the user's form input, the average response or individual participant response is passed into the response template here, and the resulting HTML is sent back to the JavaScript AJAX function here. It's returned to, let's take a look at that. So once this is returned, the HTML is then appended to the DOM to display the two responses side by side. So next up, the average response endpoint uses the same average response method as the previous compare responses endpoint to generate the average response as discussed earlier, and then this response object is passed into the average response template, which then renders the average response. No form elements are used here, so this is just a kind of a static HTML which is rendered. The create PDF endpoint uses the same form and AJAX method to collect the responses the administrator desires within the PDF. If we take a look at the HTML form, you can see some different form controls. So here we have a multiple select. So this is for selecting if you want specific responses from different users included within the PDF. And there's also checkboxes for including the average response for over all responses in the PDF, or you can select to choose all responses instead of selecting them all individually. This data is then passed back through the server using AJAX, and the create PDF method is called. So let's take a look at the create PDF method. The create PDF method within the parsing package then uses the options submitted from the form to generate the HTML of these responses, seen here. Using the same HTML component as in the compare responses endpoint. The PDF is then generated down here using the PDFKit package and is stored within the file system. The file path for this file is then sent back to the AJAX function, which sent the form options originally, and this download PDF JavaScript method is called, which downloads the file at the file path within the browser. So the reason why here we have we hash the HTML is because we want, say if the administrator submits a form with some options, it will generate the PDF and send them the file path. But say later on, if they choose the same options and want to download the same PDF, as none of the HTML would have changed, the hash would be the same as previously. So we can use this hash to then, instead of generating another PDF, just simply returning the existing file path for that PDF. So we don't have to use an expensive PDF generation method to create another PDF that already exists. So instead of generating another one, we just send them the existing file path and it is downloaded from the server. Okay, so going into the final module we'll be discussing in this video, the API module, which gives administrators access to data that's they have created or they've created by the way of their studies. So in order to protect the endpoint, we can't use any of the other previous admin required or login required decorators that were used before, because there's no interface to kind of log in or interact in such a way. So I use this Flask JWT extended package, which is a JSON Web Token kind of authentication method. So in order for an administrator to authenticate themselves to gain access to the endpoints to retrieve data, they visit this /login method, and within the request body, they send their username and password details, and these are authenticated similar to how the login method in the authentication module is performed. The user is obtained from the database, and their password is hashed and compared against the one stored. If this criteria is met, the Flask JWT extended create access token is called and is provided the user ID as an argument to the method. This creates an access token with their identification embedded within the access token, and this access token is used within all subsequent requests to the API endpoints. When you're sending a request to one of these API endpoints, this decorator here, also implemented by the Flask JWT extended package, checks this access token is valid, and if it is valid, it grants access to the endpoint and doesn't otherwise. So looking at some of the endpoints, there's a lot of endpoints within this module. In fact, there's an endpoint for kind of each table within the database, so an administrator can extract kind of all the information possible so they can gain the most amount of knowledge. So let's take a look at just a few of these endpoints. So say if an administrator visits /get/response/init and then so let's take a look at least some of the endpoints in this module. So say if an administrator visits /get/response and provides an integer ID number for a response to one of their studies, and also they provide their access token within the authorization header of the HTTP request. The access token is validated as discussed previously, and the response, the actual response is requested from the database, and the actual response itself is checked to see whether the response is part of a study. If the response belongs to a study that the administrator has created previously, and if it's not, or there is no response found with that ID, this error not found message is returned. Otherwise, this create response JSON method is run and is passed the response, which is retrieved from the database. You'll see a lot of these kind of create response JSON or create kind of something participant, whatever kind of methods being used, and these are basically creating a JSON representation of the tables within the database. So by passing the object, we then use we turn all of the attributes of a table into keys, and then the actual values from the database are the values in the for that key. And then there's one for every kind of table in the database here. And that is returned upon these requirements being valid. There is also another kind of API endpoint implemented for each table in the database. So in this case, it's get response / all. So each table has you can retrieve an individual tuple, or you can retrieve all tuples from the database, which you have created or created by way of your studies. So the all endpoints retrieve all of the tuples that you have created for the specific object that you're requesting. So in this case, you're requesting all responses to all of your studies. So this, again, if no studies are found, therefore there are no responses, this error not found message is again returned. Or if there is responses found, or if there are studies found, the create responses JSON helper method is run to return a JSON representation of all of the responses from all of the studies. So single objects or all objects of a given type are implemented through all the endpoints in this module. So participant you can get a single participant, or you can get all participants. Similarly with user group, you can get a single user group or all user groups. And that's the same for all objects that I've created within the project. So in this final section, we are going to be discussing the implementation of the tests. So specifically how the test application is set up, as well as the test database, and we're going to be discussing a few of the functional tests of the modules. So now we're going to take a look at the tests that I used in the project to test the functionality of the different modules, kind of each endpoint, the forms, the HTML, how it's rendered on the screen, kind of all the functional tests that are needed to check whether the application meets the requirements of the project. So in order to test it, I used this Python package called PyTest. And now what this allowed me to do is it allows me to create a new app within a test environment, which you saw at the beginning of the video. And we can create this app and also create an instance of the database. So within this, where this yield command happens is where the testing takes place, and then after the test is finished, all of the database is dropped. So the data from previous tests won't affect the current test. So if we take a look, each module has its own folder of tests. Most of them contain mainly functional tests, but a few, such as the responses package, also contains unit tests for the parsing package. So let's take a look at some of the tests implemented and I'll discuss how they work. So each test basically creates the required objects within the database in order to test the functionality. So this create participant method creates a participant within the database, and I'm using another file which contains a bunch of helper functions to kind of easily create these things in the database without having to specify all the parameters. And so here you can see the participant being created, and this client.post basically submits the form data for a login form with the created participants information, the username and their password. And these assert functions check that the response retrieved from this post are basically correct. So whether the functionality in the application meets what we expect. So we're checking that the response status code is 200, so 200 OK, and that the correct in this assert statement, we're checking that the user information form is displaying the correct label for the gender field, and this is kind of carried over across all of the elements in that form. The same kind of thing you can see throughout like most of these tests. So creating objects in a database, either requesting a page or posting form data to a page, and then checking what happens after is what you expect, or yeah. You can also see this get as well gets a URL, and we're checking that these strings are contained within the response data. So the helper functions I mentioned earlier are implemented in this file here. So a lot of the objects in the project depend on other objects. So I decided to create these helper functions, which say if you just wanted to create a single study, normally you'd have to create two card sets, a user group, and that takes up many lines, creating many objects. So what I decided to do was create this helper function, such as like create study, which uses the other helper functions to create the other objects required for this study object by itself. So all these, but also gives the option for you to specify these objects if you want to test specific functionality of some sub objects. So as I mentioned, each module has their own tests, and they're checking the functionality that's been described previously under different kind of circumstances. Some are checking that upon posting a form that all of the fields are present in the database, and that the correct interface is shown, or sort of things like that.